Chapter 2 is entitled Describing Distributions with Numbers. And really, if I could summarize what this chapter is all about, it's trying to do mathematical calculations on quantitative variables to understand the data that we have in a better way, to sort of analyze it and try to make some conclusions about it. Starting with sort of the most basic, the mean and the median. Now, these are measures of what we call central tendency, but it's sort of like if we were looking at data and we wanted to ask ourselves, what is like the center of this data? What's the most average number? What is the middle? And those are all things that if we're trying to describe a population with a simplistic answer, those are different ways of doing it. So let's start off with the mean, and often the variable x is just a normal variable that we use for equations or whatever and so forth. But if we put x with a little line over it, usually that is going to stand, well, in the context of statistics, that means that's going to stand for the mean, or another word for that is the average, or technically there are a lot of different ways to take an average of two numbers, but technically it's called the arithmetic average of numbers, which again is just what we define to be called the mean value. An average is is how you would think, like how most people would think about, like, say you took two tests, you got a 95 and a 90, and you want to know what's your average. Well, you add up the scores and divide by 2. That's kind of averaging them out, figuring out, well, what's in the middle ground. I don't know if you've ever really thought about why it makes sense to add them up and divide by 2 or divide by the number of data points. But it's sort of a way of saying, well, if you had, say you got 90 on every single exam, let's say you had 3 exams, you would take 90 times 3. That would give you your total score. And the way of taking an average, typically we don't get the same score on 2 or 3 exams. So say we took 2 exams, we got different scores. Well, if we add them up, that gives us our total. Now dividing by 2 would do exactly the opposite of multiplying to spread out the exams. So it's kind of like synthesizing all of those exams into that number. And that's kind of why we want to add them all up and divide by the number of so what we call observations. And just meaning like how much data do we have in our sample? Like looking back at the data we were using in the last video, there were 10 students. We would say those are our observations. We have taken data for 10 people, and n is the variable that our book uses very commonly to describe the number of observations that we have in our system or in just our sample space. So if we look at the way, and our packets often include little snippets from our book, like definitions or formulas, things that I think are useful for you to have on handy. But basically it says that x bar is equal to x1 plus x2 plus ... xn divided by n. And I just want to talk a little bit about the notation, since that's not necessarily everybody's strong suit. But all this is saying is I want to take x1, which just stands for, well, what's my first data point? What's my first value for that variable? Plus x2, the second, plus ... implying adding every single data point up for x all the way up until xn, where n being the number of observations is saying, well, that's the very last one. So basically add the first through the last, add them all up, and divide by n the number of observations. So, again, like returning to my example, say we got a 90 on one exam and a 95 on the other. Well, that would be x1 and x2 would be our scores. We would divide by 2 the number of exams that we took. That would give us our average. And it also is given to us in compact form, which we often refer to as sigma notation, which I also wanted to describe what it means. But this is just the same exact meaning as up here. It says 1 divided by n multiplied by sigma xi. And the sigma xi is a notation which this isn't exactly proper mathematical notation, because a proper sigma notation would actually have something below and above the sigma indicating where it starts and ends. So I'm going to go ahead and edit that with the proper notation. But typically, when sigma notation is left without anything on the top and the bottom, there's usually an implied starting and ending point to the sequence, or really it's called a series. And it starts at 1 and usually it ends at the last. And with statistics, it's usually going to start at 1 and end at n. That's just sort of the generic way it's always going to be for n data points. So you don't necessarily need to write that because it's always going to be that way, but I'll go ahead and write it. And all this means is just to revisit how sigma notation works, it means this always indicates a mathematical sum. You're going to take the sum of all of these things from the first to the nth, where the one on the bottom indicates where do you start, and you add up everything in between here and here. And it's always done in an integer sequential form. So let's say that we had 5 data points. This is going to be 1, n would be 5. And you're going to take every single one in between there. 1, 2, 3, 4, 5, and add up all of those. And basically, I kind of imagine, notice how this is x sub I, and it's not x sub n, but I is what's sometimes called the index or the dummy index of the sequence. And basically, it's like I'm substituting in this number I equal 1. That's going to start with x1. And then the sigma means, well, I start here, and I go all the way up to I is equal to n. So I would go 1, 2, 3, 4, 5, or I would go from 1 to however many data points I have. And all this means is I'm going to add all of those up. I'm going to add up x1, x2, x3, x4, blah, 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 all the way up until I get to xn. So I'm sort of imagining that these are getting plugged in there sequentially from start to finish, bottom to top. And notice that would be exactly what I have right here. Because up here, I'm taking the sum of x1, x2, blah, 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 all the way up to xn. I'm adding them all up and dividing by the number of things. Well, that's really all this means. This is the sum of all of the things, all of my test scores, or whatever the situation may be, and I'm multiplying by 1 over n. And as you know, multiplying by 1 over n is the same as dividing by n itself, because multiplying by the reciprocal is the same as dividing. Anyways, that's enough about the long thing. Let's go ahead and do an example. And we'll talk about the median as we go. So what the example on our packet says is Amanda scored the following on her 7 quizzes. She scored 100%, 92%, 54, 91, 83, 99, and 90. It says find her mean and her median test score. And it also asks us what would her average be if her low score was dropped. So let's just go ahead and start with the mean, since that's what I've been blabbering about for the past however many minutes. But again, we like to use the X bar to represent mean. Whenever you see that, that's usually where your brain should go, especially in statistics. That means the mean, and you'll see it in other formulas throughout the semester. And that always means average. So to find her average quiz score here, it says test score, but that's typo, meant quiz score. We want to add them all up and divide by the number of objects. So it looks like she's got 7 test scores. So we want to first say, well, what's 100 plus, we could literally write it all out. Of course, we can use a calculator to do all this. Plus 91 plus 83 plus 99 plus 90. And we're going to divide that by the number of things, in this case, 7. Let's go ahead and toss that into our calculator to figure out, well, what is her mean test score? So we have got 100 plus 92. And this actually brings up another point I wanted to mention. The TI-84 is what I'm going to be using almost always to do math. And I'll be teaching you how to use it and do various different things with it as the semester progresses. So I'm going to recommend this on the first day of class, but I'll just go ahead and say it again. This is the calculator I recommend getting if you don't have one. I will always let you use this on your exams, whereas you won't be able to use a lot of the other resources like the computer on your tests. So obviously using a calculator makes math a lot easier in a lot of cases, because doing all this by hand, most of us don't want to do that, including myself. But anyways, it looks like her mean is 87. And again, what's the point of this? I'll go ahead and circle that and write the mean here. It gives us kind of an average, like what's her general score? If you take them all into context, she got some that were really high. It looks like only one that was really pathetic. But at the end of the day, her mean score pretty good. B plus, whatever you want to call it. Looks pretty good. And another question asks us, well, what would that average be if one of her low scores was dropped? Now, in our class, certain like homework problems or whatever, we might drop the low homework. And really, I think this is a pretty good policy with certain things. I'm not going to drop exam scores for most courses, but sometimes, like with quizzes, there might be times when you run out of time on a quiz, you might get sick, you might have to miss it for various reasons. So I think it's usually fair to drop the low score, because sometimes you just phone it in and, you might have one that just you did poorly on. And I don't think your grade should necessarily reflect every score, but obviously it should reflect the overall progress. But anyways, let's just look at what her average would be in that other case. So we're going to drop her 54. Basically, we would add up every other score, pretend that one didn't happen. And this is kind of a common process for certain grading systems. And note that we want to not divide by 7 anymore, because if we are dropping a score, we would want to adjust our number of observations down to just 6 here. And so her total score was 609. So if I subtract off the 54, that should give me the sum of those 6 numbers. And then if I divide that by 6, we should have what we're looking for. So looks like her score would have been much better, obviously dropping that 54, because that 54 is really hurting her grade. But, gives us an insight on averages. And I just thought this was kind of a interesting look at it. And at the end of the day, that gives us an idea of mean. So this would not be our true mean, but kind of like an adjusted mean with a low score being dropped. Or you could say, well, what if we drop the high score? Or, take certain other conditions into account for whatever reason. Now, let's go ahead and address the median. So median is another type of way of measuring central tendency. Instead of looking at a calculated average, it's more of like, what is the very middlemost number? If you line them all up in order, what's the number in the middle? That's always going to be our median. So with her 7 quizzes, they're not in order. It's a little bit harder to say. You don't want to just pick the number which is in the the middle visually when it's not in order. But that's kind of the idea. So what I'd always start by doing is rearranging your data in numerical order. So here we have 7 data points. 54 is the lowest, then 83, 90, 91, 92, 99, and 100. Or also, if you have a box plot made already, you can actually find the median using that. And actually, we'll do that for the next question on the lecture notes. But basically, here we go. And then the median is always what's the number in the very middle. So whenever you have an odd number of data points, and that's kind of what the snippet from the book says as well, the median is just going to be the number in the direct middle. So we had 7 data points. If you divide that by 2 and round it up, that would give you your median entry value, which is the 4th entry. There's 3 to the right, 3 to the left. So the one that's in the middle is obviously 91 here. And that would be our median. Oops, not 90. 91 is going to be our median. And of course, if you were to drop a data point, the median would change. And another question is, what if there's an even number of data points? How would I do the median? But basically, technically, there is no one data point, which is the middle, and you instead want to average the 2 that are in the middle. We'll do that in the next video because this one's getting a little bit long. But we'll return back to our data with our 10 students, look at their age and their GPA, and we'll go ahead and calculate mean and median there as well.